Okay, so till yesterday we completed till over here, yes or no? Like, what was the center of mass and all of any kind of a problem? Yes. Hello, can you hear me? Okay, so now today we'll start with some sort of problems. Let's imagine, like, let's suppose there are two masses, 3 kg and 2 kg, and this 3 kg is at 0 comma 0 and this 2 kg is at 10 comma 0. Got it? Find the center of mass. Find the position of center of mass from both masses. Yeah, from both masses. See, both masses are, see, center of mass will be at some distance. Yes. So you have to find where it is located from mass 3 kg and where it is located from mass 2 kg. Yes, yes, yes. So what was the formula? R1 was given as, yesterday we got to know that R1 is M2D by M1 plus M2. So distance is given now, 10 centimeter or 10 meter, whatever it is. Let us call it as 10 meters. So what is R1? R1 is, if I measure this, let's say this is center of mass and it is located at distance R1 from 3 kg and R2 from 2 kg. So R1 will be equal to M2D. M2 is 2, D is 10 divided by M1 plus M2. So this is how much? 20 by 5, which is equal to, and R2 will be M1D 3 into 10 divided by 2 plus 3, 30 by 6 meters. So without even, if you know 1, you can also know 2 because R2 is D minus R1. Yeah, this formula I can use. Go ahead or not. Now, let us start with some kind of uniform density object. Like if I give any uniform density object, means the density is uniform in that, okay, then what will happen? The center of mass for those bodies is present at its geometrical center. Where it is present? Are you able to get me or not? It's totally present at its geometrical center. Yes. So let us take one example. So let's suppose there are two rods. Okay. One horizontal and one vertical. Right or not? And Uh, let's suppose the length of both of them is same. Got it? And masses are also what? Same. Now, if this is your y-axis and this is your x-axis, right or not? Then idea is simple, that if these rods are placed over here, then find the position of center of mass. If the rods of mass is m and length of the rod is l. Question is very simple. Find the position of COM of this L-shaped object. Okay, which is made using two uniform rods. It's easy only. Think. Tony, what will be the answer? Be fast. It's easy. What's the point? See, the center of, see, for these kind of geometrical object, we will find the effective center of mass. What we will find? Effective center of mass. Yes. So, like if this is rod of mass m and length l, the center of mass will be at exactly L by 2 comma 0. Yes. For this own center of mass will be at L comma L by 2. Yes. And masses will be m. So effective, if I want x center of mass totally, then it will be what? M1 capital M, x1 is L by 2 divided by mass is, total mass is M plus capital M. So this is L by 4. Are you able to get me or not? Are you able to get me? L by 4, or how much it will come? Array, wait. Sorry. I made one mistake. This is also L over there or not? ML by 2 plus ML. 1 minute. Yeah, can you hear me now? Yeah, so it will be M plus M. So this will come as 3L by 4. Why COM? M plus M, 2 plus, okay, 3L by 4, correct. Yeah, M L by 2 plus M plus M. So it is L by 4. So basically, that means that the center of mass is like, look over it. Let's suppose if I can join this line, yes? So remember that center of mass lies over here in this line. Not. Yeah, this is that coordinate of COM, which is 3L by 4 comma L by 2. L by 4. Are you able to get me or not? Is that clear? 1 minute. Next class onwards, next chapter onwards, I'll make on black screen. Means I'll keep the background as black screen. Is it clear now? Okay, so basically in position vector form, we can write what? R vector is equal to, sir, 3L by 4 I cap plus L by 4 J cap. Yes? Okay, can I move ahead? So see, in exam, in NEET, that this was not the question. In NEET, they asked that what is the angle made by this center of mass with respect to the origin? Are you able to get me or not? So if we know this 3L by 4 and L by 4, finding angle is easy now because I can directly write tan theta is equal to perpendicular is how much? L by 4 and base is how much? 3L by 4. 4 cancel. So theta is equal to tan inverse 1 by. So this is the angle where my particular center of mass is present. Are you able to get me or not? Confirm. So now, based on this approach only, let's do one good question. Okay. Once again, let's suppose this is your y-axis and this is your x-axis. I create a rod of this shape. Okay. A rod is made like this. Got it? Means that perpendicular rod is now hanging vertically like this. Are you able to get me or not? Okay. And each rod has mass m and length l. Both parts of the rod has mass m and length l. Question is, if this angle is theta, problem is uh, find the theta, find the theta for which the rod hangs in equilibrium. So remember, see, now this question is like finding it is like You will say, sir, how to do, what not to do, what to say, what not to say. You see, the center of mass of this rod is over here. Yes. And center of mass of this rod is over here. Are you able to get me or not? Yes. So question arises where the net center of mass should be present such that the whole system remains in equilibrium. So basically, we can join these two lines. No. So that's your question to calculate. I'll give you one hint. See, remember, we are just, see, we'll calculate this theta later on because it is a concept of rotational also. Okay. We are just marking where the center of mass should be there. So for these kind of sophisticated system which are hanging vertically, the center of mass would always exactly lie at the vertical y-axis such that they should remain in equilibrium. Yeah. So where does the COM should lie? So COM should always be lie vertically, okay, below the hinge. Got it? In order to stay in stable equilibrium. So where does your center of mass should lie? Always it should lie in the vertically below hinge, vertically line below the hinge. Are you able to get me or not? Such that they should always remain in a stable equilibrium. Are you able to get me? So based on this idea, you have to think that how to shift the center of mass over here. You can mark like this, where this is L cos theta, this is L sin theta, then what will be this length, and when you will prove it, you will see that it is exactly lying over here in this line. Are you able to get me or not? Is that clear? So this is the idea of center of mass. It says that whenever I consider a particle, whenever I have some combination of particles or something like that, they must lie in which kind of a line? Line of vertical axis. Are you able to get me or not? Is it clear perfectly? Okay. Now let me give one more question. But before we can without wasting time. Now instead of doing one more, let us do one more time. Let us now you think, let's suppose if this is y-axis and I placed 4 square plates. Yeah. Or let us place 3 square plates. Let us do not waste our time. Okay. So I have placed 3 square plates like this way, such that this square plate lies exactly at the center of the square. So and each square plate has length how much? Length of the edge is a, and masses of each square plate is also how much? Same, which is m. Got it or not? Then find the center of mass of the given system. Do it fast. Think about it. It's easy only. Mm-hmm. First you have to write the CM of each mass. Correct. And then you have to think. Then you have to find the total center of mass. So basically, if this is A, this center of mass will lie at A by 2, comma A by 2. Yes. Well, let us call it this block as A, this block as B, and this block as C. So COM of A by 2, comma A by 2. COM of B, this is also this will lie over here or not. So this will be exactly at A by 2 plus A. Yes or no? So that is 3A by 2. Yes or no? So COM of B, A by 2. And for this, it will lie over here exactly. So it will be A by 2 means A, comma A plus A by 2. Yes. So COM, yeah. So A, comma 3A by 2. So you can apply na X center of mass and Y center of mass equation. M1 X1 plus M2 X2 plus M3 X3 divided by M1 plus M2 plus M3. So what I'll get over here? M1 X1. If I do, that means M into X1 is A by 2 plus M into 3A by 2 plus M into A divided by total mass, which is how much? 3M. So we can get this idea or not? How much is this? 3 plus 2, 5, 1, 6 by 2. So that is 3, 3MA by 3MA. Yes or no? So 3, 3 cancel, MM cancel. So this is exactly equal to A. Are you able to get me or not? Y center of mass, M1 Y1, M2 by 2, M3 by 3 divided by M1 plus M2 plus M3. So this is how much? Same M A by 2 plus M A by 2 plus M into 3A by 2 divided by 3M. Are you able to get me? So how much this will come? This is 31415 5 MA by 2 by 3M. So this is 5A by 6. So ultimately the position vector of center of mass is what? It is AI cap plus 5A by 6 J cap. That's your answer. Are you able to get me? Okay, now let us give our heading the center of masses for our continuous object. Okay, So basically, I earlier I had taught you that how to cut the objects or not. Yes. Yes. So we are going to require. Okay. So in that, like, I'll share the for YouTube guys. I'll share the video of that thing in this playlist only. I'll mark it. You have to watch that before watching this. After continuing this, before continuing this. Yes or no? So for continuous objects, we said that there are three kinds of geometries. Yes or no? One is linear objects, linear, yeah, 1D objects. Other was surface or 2D objects. Yes. And third was volume or 3D objects. Yes or no? And for each one of them, we have different density factors. We say that for this, we define linear mass density. And this lambda is exactly equal to mass by length, and that is also equal to chota mass by chota length, and it is also equal to dm by dl. Yes. And for that, we usually take a straight rod and ring. This was our condition. Yes or no? Surface, we define surface mass density, which is denoted as sigma. We told that sigma is exactly equal to mass by surface area, which is equal to chota mass by chota surface area, and which is equal to dm by dA. Are you able to get me or not? This is applied for rectangular sheet or a square sheet, disc, uh, hollow, and hollow 3D objects. Yes or no? That day I told you that hollow 3D objects are actually two-dimensional geometrical objects. Are you able to get me or not? Yes. For this, we define volume mass density, which is denoted as rho. And this implies rho is equal to what? Mass by volume, chota mass by chota volume, and which is equal to dm by dv. Are you able to get me or not? And for this, we told like all 3D solid objects comes under this category. Are you able to get me or not? Is that clear? Yes. So we are going to use this. We are going to use totally the center of mass idea for it. So what does center of mass says? Like, see, if I take, let's suppose any kind of continuous object is there which is present over here, and I want to find its center of mass. This is x y axis and this is x axis. So how to find it? There are so many masses present over. So we can see now that this mass is there, this mass is there. So idea is just consider a small mass. Which mass? A small mass dm. Yeah, which is located at some x and y coordinate or not. Tell me yes or no. Now see the position vector of this dm I can define. Similarly, this thousands of dm can be possible also or not. Tell me yes or no. So if I write x center of mass as m first dm into x second dm second x coordinate, x1, x2, and so on. It will go like this way or not, by total mass. Yes. So the idea is, so how to find total mass? Total mass is also what? Integral dm, means sum of all these dm's and all. Yes or no? So the idea came into people's mind that as we are doing all these sum, we can write it in form of integral form, because this is just a summation. Yes or no? So they told, let us write this as dm into x of dm divided by integral dm. Similarly, y center of mass was defined as integral dm y of dm divided by integral dm. Now, remember, these x, y are what? Coordinates of infinitesimal mass, not the center of mass. Okay. Yes, remember that. This is the biggest role which thing. So, x comma y comma z are the coordinates of infinitesimal mass considered. Are you able to get me or not? Is this clear? And remember, if I do integral dm, we get what? Total mass of the object. Are you able to get me? So, see, if I have a solid rod, we know that for any kind of a rod, the center of mass lies at the L by 2. By logic, we can know. Yes. But what if in the rod, the density starts to vary? So, first example we'll take is variable density linear rod. Are you able to get me or not? So, just imagine like if I have any kind of a rod, wait or not, or yeah, this is its x-axis. Got it? And means at this point x is how much? 0, and then it is x is equal to L over. Means total mass of the rod is m and length of the rod is how much? L. Are you able to get me or not? Now, by logic, the density is going to be present at L by 2. Are you able to get me? Now, the question is that if the rod is non-uniform, and the density of rod is given by lambda is equal to a plus bx. Okay, and mass is not given, just length is given. Got it? Then find the center of mass of rod. Do it fast. Tell me what will be the answer. Done. Should I help? 1 minute. Let me check what we did today. Let us be fast. See, now, here it is saying that every point on this rod has a density which is varying in the rod. Yes, means it's like mass over here is 1 kg, here it is 2 kg, here it is 3 kg, here it is 4 kg, here it is 5, 6, and so on. Yes, it becomes very hard to find the total mass of the object or not. Yes, so how to define the total mass? That's a big question. So let's suppose if this is my rod and I consider a position where, let's suppose this is, I have to consider now. See how to find the rod. Here it is non very means here the density is itself varying, so we cannot determine easily. So idea is simple, as I have done earlier, to find any kind of mass in a variable system. First idea is consider a small mass whose length is dx and it is located at x. Any continuous object, what is the idea? Dm, its length, and it is located at some distance. Are you able to get me or not? If it is a linear object, if it is which object? Linear object. So what I'll do? Simple. We know that lambda is given. Lambda means bada mass by bada length, and that is equal to chota mass by chota length. A small mass by a small length. Yes or no? So we can write now. Dm is equal to what? Lambda into dx. What is lambda given? This implies dm is equal to a plus bx into dx. Now for any kind of, which kind of system? Non-uniform system or continuous system without x center of mass will be given as integral dm into x divided by integral dm. Yes, so I'll write dm is what? A plus bx into x dx and divided by integral a plus bx into dx. If I do, then this is nothing but my total mass of the system or not. And then I should take the integration from where to where? 0 to length L. Yes, because whole system is varying from 0 to L. So what I'll get? A plus b x square by, see this one, if I do the integration, then this is a x dx. Yes, so it will become ax square by 2 plus bx square, so it is bx cube by 3, and both of them will vary from 0 to length L, divided by, denominator term is easy, Yeah, it is ax plus bx square by 2, 0 to length. Are you able to get me or not? Is that clear? So ultimately what I'll get as answer, a l square by 2 plus b l cube by 3 divided by al plus bl square by 2. I can take l common, na? So it will be al by 2 plus bl square by 3 divided by a, a plus bl by 2. So now you just do solve it and find this LCM. Are you able to get me or not? Is this clear? So ultimately your answer will come as, I'm writing it directly, 3al plus 2bl square divided by 6a plus 3bl. This is your answer. This is the position of center of mass for a uniform rod which has a variable density. Are you able to get me? Clear? Okay. Now let us include some more question. Now, so this was rod. Now the second type of your, you can say that continuous object is ring over here or not? Yes. So second one is ring. So give the heading, semicircular ring. Why semicircular? Because for normal ring you know the answer. Yes, it is at exact how much distance. R L means it is at the center. Yes or no? For full ring. Yes. Yeah. So where, what happens? We have to consider for the semicircular one. Yes or no? Correct. Yeah. So 1 minute. Let me just bring it over here. So this is my ring. Okay. And I want to find its center of mass. Yes. So this is my shape of semicircular ring. Got it? Now it has, let us consider that the length of the ring is L. Sorry, radius of the ring means, let us mark what is happening. 1 minute. I'll just wait and open it. I have to update these. I have to see which app is working fine. Actually, there are so many apps nowadays, but this one used to be best. Now it is not best. Okay, so let's suppose this is my ring. Got it? And one is x-axis, another one is y-axis. So let's suppose this is your x-axis and this is your y-axis, and you want to find the center of mass. Right or not? So how to calculate that? That's a big question. Now see, for a full circular ring, yeah, for a full circular ring, the center of mass is present at the center. Yes. But the main point is where it is present for the normal case. So let's suppose mass of the ring is m and radius of the ring is r. So idea is we have to Okay, they are considering the y-axis from origin. So let us consider from origin. That's also better. That y-axis, we will see. Basically, the idea is from origin, it is much more easy to calculate because it can be considered as symmetrical. So yeah. So first idea is, once again you'll have to start with this idea that consider a small mass dm or not. Yes. If total mass of the ring is m and radius r, so I have to first consider a dm mass. Yes. Which exactly makes some angle theta at the center of the ring. Yes or no? What it will make? D theta. Yes. But it will be located at angle theta from the base of the ring or not. So if I look into the coordinate of this ring, what will be its coordinate? It will be, if this is r, then this is r cos theta, r sin theta, because we have to consider the coordinate of dm. Yes or no? And length of this dm will be how much? R d theta, arc length. Yes or no? So now, as I told you earlier, that ring is also, yeah, any kind of green sound is not coming now. So ring is also a linear object. Are you able to get me? Now, if it is a linear object, we can define lambda for the ring. Lambda is equal to what? Bigger mass by bigger length. What is the length of the ring? Pi r. Yes. And that is equal to a small mass by a small length. A small length r d theta. Yes.